All right, with a time series, we're composed of quantitative entries taken at regular intervals over some period of time. Okay? So the example given here is amount of rain measured each day for a month. All right, so it's quantitative entries taken at regular intervals over a period of time. So every day this farmer wakes up and he goes over and he checks his rain gauge, and the rain gauge has like how many inches of rain it happened over the night, right? Whatever. Okay? So, and then maybe it filled up like 1.5 inches, right? Okay. So the farmer, maybe at some regular time interval, goes out and like on day one. Okay, on day one, Farmer Brown, whatever, he goes out and measures it, and it's 1.5 inches. Okay. Day two, goes out and measures it, and there's no rain. Day three, goes out and measures, and he's got 2 inches of rain. Day four, goes out and measures, and maybe there's 2.2 inches of rain. And you just keep continuing this pattern the same time, regular intervals over some period of time. Okay? So the time series, how we plot this, since it's a time series is a function. Now, what do I mean by a function? That means every input, here the input is the day, okay? There is exactly one output, meaning number of inches of rain. Okay? So day one, day two, day three, day four, day five, day six, day seven, day eight. Let's just do it for a week, right? So we measure it. We measure over rain measured each day for a week. That way we don't have to do 30 of those, right? So I'm going to have 0 inches, 1 inch, 2 inches, 3 inches, 4 inches of rain. That'd be pretty crazy, right? So the first one, day one, I had 1.5 inches, so I'm going to put a dot at 1.5. Day two, there were 0 inches of rain. Day three, there was 2 inches of rain. Day four, there was 2.2. Now we're just going to make stuff up. Day five, maybe there was 1 inch of rain. So I'm going to go back down to 1. And day six, maybe there was 3 inches of rain. And day seven, it came a big old monsoon and there was 4 inches of rain. So how does the time series work? So we go up, down, over, connect all your dots, okay? And so that's the idea, okay? So we're just connecting all the dots. And this is a time series, okay? So the point of all these graphs is we take a bunch of numbers, okay? And then we put it into a picture. That way we can extract information a lot quicker. So maybe you say, look, oh, as the week went on, it rained a whole lot more. By the end of the week, it was raining a lot more. Okay? How is this different than a scatter plot? Is this any different than a scatter plot? Well, let's think about it. With the scatter plot, go back to this example we had here, this scatter plot. We saw where we had two different people who have both worked the same number of years, and one of them made 33,000 and the other one made 30,000. Okay? Now, why that's the case, I don't know, but it definitely happens. Okay? So here's a scenario where there's exactly one input of 6, but there's two different outputs, one at 30,000 and one at 33,000. Okay? And so that defies the rule of a function and therefore makes it not a time series. It can be a scatter plot though. So technically, all scatter plots, all time series are scatter plots, but not all scatter plots are time series. Okay, so this is a time series. Okay, actually, take that back. Here's the deal. Here's the big difference. Time series here. A time series, you're taking over regular intervals. There's nothing up here that says we had to do it over regular intervals. In fact, 2 skips 3 and goes to 4, but then it goes to 5, and then it does 6, 6, and then it skips 7 and goes to 7, 8. So that's not even a time series because they're not taken at regular intervals, okay? A time series takes regular intervals like maybe once a day, once an hour, or once every minute. You know, maybe you're monitoring baby's temperature after they've had a fever to see, you know, what the temperature is each hour to see, you know, what if the temperature is going up, going down, staying steady. So doctors may want to, you know, measure that body temperature hourly or even by the minute if it's really serious over some time period, maybe like a full day or 3 days or whatever it is. That is the idea of a time series. This x-axis is in time. Okay? So it's in time, it's independent.